good morning all. Today's topic of the webinar is Analyze Multidimensional Data in ArcGIS Pro and ENVI. You may use different types of data sets like multispectral, hyperspectral, like namely Landsat, Sentinel and all. Apart from these satellite data sets, we have multidimensional raster data sets. So let's have a look how this helps us in our solutions. So the topic and agenda for the webinar is we have to understand what is multidimensional raster data, the multidimensional raster data in ArcGIS platform, reading, analyze, visualizing and exploring this data, understand the algorithms, sharing and consuming data and use cases. So before we get into the detail, I would like to provide an overview of image and remote sensing capabilities in ArcGIS. At the center, we have our image management capabilities, which enables current management and accessibilities. Now, and you can see here map production. The map production capabilities focus on tools to generate derived imagery products, and such as orthophotos, DTMs, and 3D essays. The analysis and AI capabilities, which are the focus of the session, to provide tools to extract information from imagery. You can perform classification, segmentation, change detection, and much more. Then we have visualization and exploration. These capabilities offers you a range of tools to enable an interpretation of imagery, whether it's drone imagery, aerial imagery, or satellite imagery, or multidimensional rasters. As you might have known, that each year there are many satellites are launching, which covers the Earth, ocean, weather, different climate and temperature. And also, the temporally it provides the long time series data, like hourly and secondary basis. Also, we are getting the data which is relevant to the climate, temperature, and other rainfall and other parameters. So these data sets we can access and we can see as a multidimensional. ArcGIS Pro has capabilities to analyzing these data sets in a 2 dimension, X and Y. Along with that is a time, which refers to T, and depth is J, and some other variables like derived and like different imageries. So each slice contains certain information which gives the different variables. So NetCDF can also access and work on the different structures. Either you can talk about the ocean data, where you can work on the sea temperature, or weather data, or land like soil moisture, NDVI, and land cover. You can use these data sets and perform analysis and understand what's going into the future. So you can do predict and forecast and understand what's the next 40 years, next 100 years, or so on. So NetCDF files are leveraged within ArcGIS platform in a 3 file formats: NetCDF, Grid, and HDF. Along with that, we have our own native file format, which is a cloud raster format, and we have multidimensional image services. You can create the multidimensional rasters within ArcGIS platform. And also, if you have a series of raster, you can create a mosaic data sets, then you can perform analysis. You can visualize time, latitude, longitude, and space, and also you can transpose it and understand the different variables. So we can access this multidimensional rasters in ArcGIS. The main reason what we can say, we can ingest the data directly in the ArcGIS platform. We can manage all multidimensional raster data sets in desktop and web both places, and also we can visualize in 2D and 3D. We can perform analysis as using Pro geoprocessing tools or as Python APIs, ArcGIS, many more, and also we can share this data. We can share this data to the within the organization and outside the organizations. So what we can do, like I can say, we can access this data in ArcGIS and ENVI both the platform. GIS and remote sensing professionals who are working on desktop platform, they can consume the multidimensional rasters in ENVI and ArcGIS both the places. But developers who want to develop the apps and wants to consume as a service layers and wants to perform the analysis, they can use ArcGIS API for Python or ArcPy and they can perform analysis. In terms of analysis, we have two set of tools, geoprocessing tools. One is image analyst, another one is spatial analyst. These tools help you to perform analysis and to generate trend raster, predict raster, and also do the forecasting analytics. So how we can read, manage, and explore this data in ArcGIS Pro. So let's see. Here we have next generation of desktop called ArcGIS Pro. This is 64-bit application. You can directly add the multi-dimensional raster data and access in ArcGIS Pro. So you can direct ingest, no need to convert. So in raster file formats, and we have geoprocessing tools. With the help of these tools, you can create subset and mosaic multi-dimensional data sets. And we have image analyst tools, multi-dimensional tools, which help us to perform, aggregate, and do the trend analytics and do the compute changes and all. And we have multi-dimensional tools under the spatial analyst, which help you how to create, aggregate the multi-dimensional raster and generate a different multi-dimensional analysis. So we can read this next series of scientific data sets directly, but you can see in input there is a certain variables. Every variable contains certain information, and when you have to visualize this, it has come as a slice mode. So either you can access any of the file format, whether you can get the access as a raster layer, feature layer, table view, or else you can access as a services. Once you can access this data, we can read and visualize this data in 2D and 3D both of them. So while the new voxel layer is specific to NetCDF files, I have to mention it here because it's a super cool. You can now add volumetric or space-time cube NetCDF files to local scene in ArcGIS Pro as a voxel layer. We can also create and read and analyze this multidimensional data in ENVI. As you know, ENVI is advanced remote sensing software. You can access this data, and also you can use ENVI Ideal to create and also to read this NetCDF files and perform analysis and create the band animation and to create the time series animations and all. So nothing that we can also see that how we can perform use this data and perform different types of analysis. So when we talk about perform raster analysis, so we have ArcGIS Pro and also we have Enterprise and we have ENVI. So you can leverage Pro, ArcPy tools, and Enterprise. You can use ArcGIS API for Python, and you can do some other raster functions which is not available. And also we are providing set of raster function tools, geoprocessing tools, which help you out to perform different type of multidimensional analysis. With these available geoprocessing tools, you can do multidimensional analytics. What are the analytics you may perform? Like if you have a lot of data, you can do and we can data aggregate this data and perform analysis. Like you want to detect anomalies, you want to perform trend, like you want to understand how the temperature moving, or you want to find statistics over the year that how really climate has changed, or else you can predict the rainfall or climate or temperature for the next 50 years or 40 years or 100 years as required. And you can also perform different statistics here. Not only that, you may be looking for different custom algorithms. So we have here on-the-fly analysis using raster functions. These functions help you and where you can access the Python and do with the raster function template. So this raster function template, where you can access the available raster tools and also the geoprocessing tools and create your own templates and perform analysis. And you can create complex scientific models on multidimensional analytics. You may think that we have a set of tools in multidimensional and also like geoprocessing tools, but there is a lot of community science communities who also are developing tools and contributing in ArcGIS Pro. So like here, the Marine Geospatial Ecology Lab, who has developed a MGT tool which help us to perform on oceanographic multidimensional data. These set of tools help you to identify ecologically relevant oceanographic feature in remote sensing imagery. You can also building predictive species distribution, detecting spatiotemporal pattern in fisheries and other time series data. So to understand scientific data, we need to always understand the available algorithms. So here we have a set of algorithms available in ArcGIS Pro. The linear trend line, harmonic trend line, and polynomial trend. What it does, when you talk about the linear trend line, it fits the pixel values for a variable along with the linear trend line. You can see here. Then we have harmonic. So harmonic, it fits the pixel values of variable along with harmonic trend lines. You can see like the x and y axis where the time and also the NDV of the 16 days and how the trend line has fixed. Next, we have polynomial. So you can see how it fixes the pixel values for a variable along with the second order polynomial trend line. So with that, you can do and perform the different analysis, and you can see this polynomial regression audit tool, where we can see the graph between 1991 to 2013, how the trend is going on. We can visualize and analyze it. With these generated trend rasters, we can use to predict in next 10 years, 15 years, 25 or 100 years. So you can see now here how we can detect temperature in 2025, atmospheric PM in 2025 and NDVI in 2025. So now I am requesting Ubimanyu Sharma to demonstrate the multidimensional analysis. So Rudy, can you share the presenter mode to Ubimanyu Sharma, please?
Good morning, everyone. So, welcome to the webinar. So, I'll be taking you through the processing and analyzing part of multidimensional data in Esri as well as Harris platform. So, first of all, I'll thank Kiran for just taking you through how for the theoretical part of multidimensional data and how it can be accessed in ArcGIS Pro and how it can be utilized. So, starting on with this. This is the latest version of ArcGIS Pro that I will be using. So on the right side we have all the toolboxes listed. So first of all, starting with that, as explained by Kiran, that multidimensional data contains a lot of variables in X, Y, and Z as well as in time format. So handling them can be really tedious and tiring for the user to and later on analyzing them can be really tedious. But in ArcGIS Pro, it's very simple to use. It's just like adding your same way that you add other raster, you can add your multidimensional layer also in a similar way and start analyzing. So first of all, I'll be taking my demo in a way that Kiran explained, that how we can read the data, how we can analyze the data, and how we can share or explore the data. So first step will be to add our data. So using add data, I'll just add my multidimensional data that I'll be using. So you can I'll select my variable and see how easily it's added. So in this demo, we are using the netcdf file that contains sea surface temperature data downloaded from the NOAA agency. Then after selecting this sea surface temperature data, you can see the multidimensional ribbon pops up over here in the ArcGIS toolbar. So in the current data, we are using the netcdf sea surface temperature data from 1980 to 2015. can see here the ribbon pops up. So to better visualize it, you can use the visualization purpose for it to see how it's changing from 1980 till 2015. So you can see the animation is created automatically, and you can scroll in between the ribbons to change your analysis to view your trend, how it's varying. And now to analyze this multi-dimensional data, sometimes the researcher wants to analyze the data from a particular time period till a particular time period. For example, it's the data from 1980 till 2015, but I don't want it for the whole 35 years. So what I can do is I can define my start time, I can change my start time, and I can also define my end time. So only those data available in those time periods will appear. And one more thing to add is like it's the data with a single variable. Some multidimensional data contains lots of variables in the netcdf file, so you can change the variables from here. Only those variables will be used, and only those slices will appear in your multidimensional data in your viewer. Now to explore into this data, we will use the multi-temporal file option. So the first thing that we are interested in from the multidimensional data is to see the temporal profile. So how it's varying along time from a particular time period to a certain time period. So just to show you, so we will select a temporal profile option from the toolbar, and to just for select an area, we will select any area near the Maharashtra coast. For example, like this, I'll define my time interval that I want to see it. So here it's the monthly data that's happening, but I want to see it on the yearly basis. So you can see the temporal profile will change from the monthly to the yearly time period. So you can see from 1981, 86, 891. So you can define the time series gap also. So it's on 5-year gap. So you can change the gap. Also, one very interesting thing to add is like when we are doing the temporal profile analysis, we want to see how the trend is varying along the time. So we want to see the trend line. So you can add a trend line directly. So you need not to generate trend lines by taking your data to then importing your metadata to your Excel sheet. So you can generate directly here the trend line. You will get the R-square value also, and you can analyze how your temperature is increasing or decreasing, and many other functions. So moving on. So multidimensional tools can be analyzed from your multidimensional ribbon over present in here. Also from the geoprocessing toolboxes that can show, like you can analyze them from the multidimensional tools that are present. From the image analysis, sorry, just I'll open multidimensional tools you can use. So you can analyze them from the image analyst also. So I'll be using this multidimensional image analysis tool for showing the further part of the demo. So now let's get started with the analysis part. So the first step is like we are using the monthly data, so we need to aggregate this data to yearly. So I am concerned about aggregating my data to the average yearly temperature. So using the image analyst tool, so aggregate multidimensional raster. So here I will use the netcdf file that I have. I'll just input. I'll give the output time, so I can define the aggregation definition. So I can define it by value. So I want it on a gap of 1 year. So I'll just do 1 and I'll run it. So what we are doing is we are converting it to the average yearly temperature. So what I'll get from a monthly data to I'll get to the yearly data. So which I will use in my further analysis for the further part. So here, if you see that layer will be added, so this is my aggregate temperature for the yearly analysis. And in the time bar, you can see now the data is coming on the yearly basis, like 1981 till 2015 till my data is present. Sorry. So the next step to move on is to generate your multidimensional anomaly. So I'll generate my multidimensional anomaly. So here the input I will be doing is my aggregate yearly temperature that I have chosen, that I have prepared. So for that, I'll just go by run. So generally this tool calculates why we are calculating the anomaly. It generally computes the anomaly for each slice in the existing multidimensional raster yearly data that we generated in the previous step. So this tool produces this data in a CRF format. So the results here display a map. It's in a scale. It's on a coloring scale like from blue, yellow to orange. So blue colors indicates that these areas are cooler as compared to the average sea surface temperature, and yellow to orange areas show that these areas are hotter as compared to the yearly sea surface temperature that we just calculated. Now moving on with the next step is to generate the trend. So in the latest release of ArcGIS Pro, we have added tools to generate trend analysis that allow us to compute trend over time. So for that, what we will do is we will just incorporate our .gdf file. We can generate a trend and we will run it. So these like whosoever is working on the multidimensional data or of a temporal data, so they are really interested how we can generate a trend, how it will behave in the further coming time. So generating your trend raster can be really helpful in doing that. So you see how easily the trend raster is the trend raster file is generated. Just and you can change your trend line type. So as Kiran explained, that there are various algorithms involved for generating your trend line type. So it can be linear, harmonic, or polynomial. So you can change it based on the requirement that you are working on. So as to interpret this, so if there is a map raster layer in a scheme of green to purple. So these purple areas indicate that these areas have shown a warmer trends over time, and greener one are towards the cooler part. So this trend can be really helpful. These analysis can be really helpful in incorporating it to your other models. Now, it's define it's the most important step that I am now about to cover. In this step, we will predict the trend raster. So we will predict the trend, how our sea surface temperature will vary in the coming time. For that, what I'll do, I'll just incorporate my trend raster that I generated. So for that, I'll say I want to do it by intervals. So the start date will be, for example, I want to generate it till 2100, 12, 31, sorry, time I'll define, right? I'll just copy it from 2050 till 2050 till 2100 December. I want to generate my trend, right? Yeah. So I can define my unit. So years, it will be years, and I'll generate a run. So this what predict trend raster is computing. It computes a forecasted multidimensional raster using the output trend raster that we generated from the previous result. So you can here see how so you can see it's generated. So its trend raster is there, and you can have analysis over that, and you can predict how your trend is. So these trend rasters can be really helpful for the government authorities, for the policy makers to make policies for the climate change and to incorporate them into their other models, and you can have your analysis for that. Now, one more. So this one was part for the for sea surface temperature. So now moving on to one more demo that we will like to cover is it's like the ArcGIS and Esri platform is not like constrained to only a single multidimensional data. Like you can just incorporate that. So you can incorporate multiple data. You can club multiple types of data for your analysis. So for in here, we are looking at an air quality data from the various stations that are installed all over the United States. So what here we are doing is just to show you how we can, it's the multidimensional data. So you can see the visualization part, how it's varying. So you want to predict what will be the analysis or what will be the analysis that will happen, what will be the prediction that will happen over the coming time. So what we can use is we can use the regression what we can use is the regression prediction. So we have it's the Bayesian kriging regression prediction model that that is accessible from the geostatistical wizard of ArcGIS Pro. So you can incorporate your multidimensional data in over here, and you can predict the output that will be coming in the further years. And for here, like if I switch on this, you can bookmark to a certain area. So I'll just go to this, so you can see how well it has predicted that these areas will be having a bad air quality index in the coming time. It may be because of high density or high pollution or industrial part over there. Now, to give some Indian scenario, like the processes remain the same. So here we are using the rainfall data provided by the IMD. So we can also utilize that. So how, you can see, you can make all your trend lines can be made. So same thing that I showed for sea surface temperature. You can visualize it, you can analyze it, and you can predict your predict the further analysis for your part. Now, this was all for the analyzing part of the multidimensional data. So the next part comes, that is the visualizing part. So for visualizing parts in the latest Pro 2.6, we have added voxel layers. So voxel layers can be used to visualize and explore your multidimensional data in a complete new way. So the first question comes to your mind is, what are voxels? So voxels are 3D cubes that can store a variety of data. So the multidimensional data contains lots of variables. So they can store that data and present those data in a 3D view. So these are really powerful tools of exploring and visualizing your data. So here is, I have added this sea surface temperature layer to the scene layer of ArcGIS Pro. So here you can see it's all data from 1980 till 2015. You can adjust the position, and you can very beautifully see how easily you can visualize it. You can analyze and see your data. Two or three. So one more we will like to cover is the carbon monoxide in the atmosphere. So what you can do is the same thing that we showed in the sea surface temperature voxel layer. So the same thing can be done for this. So you can create your vertical slices. For example, over here you can see the slice section. I can generate a slice wherein I can see how my carbon monoxide variation is changing over a particular area, and it can be really helpful and powerful tool for visualizing. So the next demo that I'll be showing is to show how you can even show your subsurface soils in a 3D view in the form of voxel layers. For this, we have used the subsurface model, which contains lots of classes ranging from peat, clay, sand, fine sand, medium grain sand, coarse sand. So this one is like this. So you can clearly see, how the 3D layers, how the subsurface layers are presented in a 3D way. You can move into one place where I have bookmarked, so you can see here how well these are happening. And to give it a better view, we can generate a section. So I'll go to section, I'll slice a section. So I'll show you how you can analyze and see it in a 3D way. So it may take some time to load for this subsurface part. So depending upon your GPU capability, so you can analyze it, you can see it and do your analysis. Uh, so one so this was for the Esri platform. Now coming on to the Harris platform. So Harris platform is a completely robust image processing platform that is giving you a power to add you work on n number of raster data sets ranging from multidimensional data, hyperspectral, microwave, and the scientific formats like the temperature data, rainfall can be clubbed to your raster formats to give it a more better interpretation and more explanatory thing. So NV can be utilized to open any type of your data, starting with the optical sensors, you name any. So it is supported in NV, and for the microwave formats, even for the scientific formats, HDF, HCDF formats are directly supported in NV. So for in here, I have used the same data that I use for the sea surface temperature. So I have it's very easy to add. So just to show you how to add it. So what you can do is you can add this data to your raster builder. You can add the various metadata that is involved. So you can add all the parameters that are restricted to the raster in over here, and you can open your raster. So you can see how well it's added. So what you can do is you can create a band animation in over here to see how the temperature, how the sea surface temperature is varying over time. So just to show you a glimpse, I can show you in here. You can see how the data is opening, how it's varying from one time to the other time. And to give it a more interactive way, you can make like the same we did in ArcGIS platform. So you can make it in a better way to present your data. So this is an average temperature data that I showed you. So I presented it in an interactive way to show how it's varying from time to time. So, and one more advantage of using Esri and ENVI parallelly is like the interoperability of both these software. So you can access all your data processing, what you're doing in ENVI to the Esri platform, and same and the vice versa part. So it's very easy to use. You can club these software, and you can really analyze them for using and doing your analysis. Now I'll again request Rudy to please transfer the sharing screen to Dr. VSSK.
Thanks, Remanyu. So, as you have seen a lot of reading, analyzing, visualizing, have you ever think that if you don't have rasters, but you have CSV file and shape file, how to create these multi-dimensional raster data sets? Here you can see I have evapotranspiration values with the content space along with the space and ET value. And I have a set of shape files. You can see these shape files here. Okay, so how I can use these data to create multi-dimensional rasters? Here I am using ArcGIS API for Python notebooks, and this notebook which we have integrated in Pro itself. Here I am importing the relevant libraries like netcdf4 and numpy as array and arc5, and also I import CSV file because my data contains CSV. Now I am just setting the data path where the data has the available input data like CSV and the shape files, and also I have given the output NC file which generated as a NC. So now I have given certain global attributes regarding the data information which contains and share as a metadata particular the raster which we are going to create. At first, we are creating dimensions. So as you know, the X, Y and time, the 3 dimensions have created. Now I am assigning the variables as a NC variable. You can see I have assigned what is Y, what's X and what's T. Then I am going to save this as a CRS because CRS is a cloud raster format which is our own native multi-dimensional raster file. So once I have done this particular thing, then what I have trying to load values as per the time. And this once the time values has loaded, I am loading the values of latitude and longitude of each and every pixel. Once I done that, I can go with the load ET values from raster. Once my raster has run, the contents has load, I can access the same shape file and use this data to again extract it to the shape file. Then I can load the existing ET values from CSV as well, and finally I can the raster which I created, it got saved. Here you can see the raster which we have created, how it looks in TIFF file, but really how it looks in NC as a evapotranspiration. So not only that, the raster we have created, but when you talk about a use case, let's see, I can monitor one oil lease site here. So here my target to monitor wind condition of oil leasing sites. There is a few oil leasing sites we have marked here. Right? These are the blocks. I want to monitor this. How can I monitor? So the same way I have created, but here I have created the different set of rasters. I use add raster to mosaic datasets to add it different type of set of grid files. Oh, how it looks. Let me show you that. You can see these are the grid file formats. It may be number of megabytes. Okay, and sometimes it's in 10 GB, 20 GB. But when I take this data to take it here, and I can, in ArcGIS Pro, I can quickly create these mosaic data sets. Once my mosaic data set is ready, I can monitor this particular leasing sites, how really wind flows. Now you can see clearly how really the wind is moving. And once it's done, I can also create a temporal. You have seen the how Vimanu has created. Same, we can create a temporal profile to understand the particular time period, how the wind is moving on the particular site. But really, I want to see these wherever the oil lease sites are there. I want to extract it exactly. Let's see the integrate part of ENVI and ArcGIS. Here you can see I am just having ENVI of the same data, the wind. But here what I am doing, I am accessing the same grid file which I have showcased you. I can see the arbitrary profile. But what I am doing, I am just enable the data which we have. Now, to visualize this data and extract the oil, I have just applied the presettings here and I am just running to the Gaussian method. You can see all these sites are clearly come up and it display as these green points. If you want to see the animation part, we have here band animation, and these band animations you can clearly see now here how the data can move and it can display here wind is moving. And I can enable it to annotate as a frame. You can also see it how exactly it looks like. To annotate it, you can also see the string file name. Yeah. So like this, you can also get the details. So once my data can done here, I can just go how to take this data to the next level, where we can talk about sharing multidimensional data in ArcGIS Pro. So sharing data where we can use a desktop, web, or device anywhere, wherever you want. The data can access and publish. You can create as apps, or else we can access this data as a service, and we can do and perform analysis. As a geoprofessional scientist, they can access this data and perform a lot of analysis. Or else, if a set of data sets and you want to access in a server, you can use multidimensional mosaic data sets. So what else? How to share this data? You can share this data as a WMS, map service, or image service. But when you want to perform analysis, so here you require as an image service. But when you want to create a map and visualize it, the map service is enough. It's a simple like how to share the feature. But once the data has shared, you can do a lot of things out of it. Like here you can see the industry solution of hurricane track. The multidimensional data help us to track the hurricane, track cyclones and all, which can able to in a browser view. We can take this to data and create a 3D view applications so people can visualize and understand how the wind is moving over the globe. Then we can have the web app builders. These web app builders help you to perform and create different web application, and you can access in mobiles, you can access in tabs and desktop, wherever you want. Then we have operation dashboard, which gives the dynamic study. So you can access and understand how much coral reefs, total coral reefs, high alert, where, and how it's moving. It's complete things. Then as I showcased the Python APIs, you can access these data sets within Python API and perform the analysis. Not only that, you can also share this data as a story maps. As someone has asked like how we get the data or how we download the data, high resolution data. As we have highlighted here, the Living Atlas. Living Atlas provide you as a service layer. You can access the sea surface temperature as a service layer. You can access the wind as a service layer. You can access the precipitation data, fire data, all as a multidimensional data sets as a service layer. And you can do on top of analysis. There are certain apps which created using the multidimensional rasters, like stream gauge observations, or as I can say, CI survey. Then you can also save your entire thing as a story maps. These story maps help you out to do and perform the different type of do the tropical cyclone analysis, and you can do the drought tracking and all. So not only that, let's see how this data can share, right, and how we can access. So what I'm doing here, I'm just showcasing the same sea surface temperature data which Vimanyu has explained and to perform analysis and all. This data I want to share on my ArcGIS Online or my portal enterprise edition. So here you can, what I'm doing, I'm just taking this data and I am sharing this data as a web layer. You can see this is the web layer where you can publish this web layer. And this web layer you can publish it as an image service. So now you can see here this data I'm going to publish as a imagery or map service or WCS service. Alright. So any service if you want, you can publish it. So let's see how the data has published. The same layer I published in my online account. And I can perform same the animation layer here itself. You can do and understand. So here you can see the data, how really it looks like. As per the time you can able to see how it's moving, the animation you can clearly see. So now I ask Vimanyu to use this data to create app and showcase it. The app she has created is now going to demonstrate. Rudy, can you transfer the presentation mode to Vimanyu, please?
So thanks, Kiran, for telling how we can share. So share data has always been the strong point of Esri platform. So you can, it's not restricted to a single thing. Like you are preparing data on your desktop, so you can just keep it on desktop. So the dissemination part of Esri is the strongest point that we have. You can disseminate it on web. You can disseminate as a web layer, image layer. So and you can do all the visualization part, representing part, all on the desktop as well as the online platform. So as Kiran explained about the sea surface temperature, so the that temperature the data can also be presented in a display. So it's also on the history platform that we presented. So what is like you can add your time slider, so you can add your index in over here. You can add all the analysis that you're doing. So we are just doing it for a single data. So for example, like in over here, I just want to see how for this area, the temperature is varying. For example, we have done it from 2008 till 2020, but I just want to show like in 2013 how was the temperature varying over that area. So you can see the file will get updated. So it's a monthly, it's a 15-day data that we are using. So you can see how now it's showing from April 1, 2013. So in this way, you can ingest any of your data, any of your parameter variable that you're working on your browser part, and you can analyze it. So one more thing we would like to show is for it's the services that NOAA is providing. So they have also done it for that. So for example, like this, you can add. I was mentioning about you can add your variables in over here. So for example, you have variables like max temperature, min temperature, precipitation, humidity, wind speed, wind direction, sky cover. So all this can be added to your tab. And for example, like this maximum temperature, I want to see how it's. So yeah, for example, like temperature. So you can see how the temperature is varying over time. Yeah, you can see how it's changing. It's pretty slow. So sorry for that. So you can see how it's changing over fly. So once you click on the previous data, so it will get changed. So all this can be done. And also one more thing we would like to do, it's also on the web platform. So you can add any, it's not working on a single multi-dimensional data. So you can club any of your data, for example, like hazard data related to, for example, higher temperature. So you can add your drought data, hurricane data to your analysis. For example, in over here, there are various models involved in the climate change, like RCP 2.6, 4.5, 8.5. So you can add and you can analyze in over here. So how you can utilize it, you can see it for your area, for how it's changing, how what was the scenario in the previous time. For example, in 1998, what was deforestation amount? If there were any cases, flood cases for this particular area. So in this way, really, you can analyze, visualize, and present your data. So now coming on again to the presentation part. So for that, for this was all about the reading, analyzing, and sharing your data. So to cover up for learning, for more learning, you can go to these resources. So we have online resources available. So you can go to ArcGIS Pro Help Documents. You will get all the tutorials about the multidimensional data toolbox, image analysis toolbox, spatial analysis, ArcPy. You can go to the arcgs.learn where you will find all these blogs in over there. You can check out those blogs and you can learn. So and also UC videos are available on YouTube or on the Esri website. So you can go out and check it over there, and you can learn from the you can learn the latest trends in the geospatial technology from these videos. You can join also the GeoNet community so as to get to be updated on what's happening in the geospatial domain for the latest trends that are coming in history platform, what is the future of geospatial technology for all these resources. You can join in over here and you will get all your mail updates on from this GeoNet community. So we have upcoming Esri India webinars in the subsequent weeks. So you can go on these links. You can register yourself. So on October 7th, we have a demo. We have a webinar planned on processing and analyzing your hyperspectral imagery. So you can see how easily you can do the analysis and the processing of the hyperspectral imagery both in Esri as well as HADIS platform. And on October 8th, we have a webinar planned on by L3 Harris, so where you can learn how you can accurately classify your image for disaster function, disaster responses. So this you can go on to these links. You can register for these webinars and have the learning of what's the latest technology for these. So thanks from my side.